Hello dear students, today we will solve one another problem of class 10th ICSE Board 2025 board exam. This problem is simply based upon principle of conservation of energy. The problem is like this: Richa weighing 40 kg leaves point P on her skateboard and reaches point Q on the ground with velocity 10 meter per second, and you have to calculate in part A, the kinetic energy of Richa at point Q, B, the vertical height of point P above the ground, use G as 10 meter per second square and neglect friction. And in part C, we have to calculate the kinetic energy of Richa at point R. While moving from Q to R, she loses 500 joule of energy against friction. So we will proceed for the solution. Here, Richa weighing 40 kg 40 kgf kilogram force 40 kgf is equal to force exerted by gravity on a mass of 40 kg. So here mass is 40 kg and we have to take the value of g as it is given 10 meter per second square. Okay, so now in part A we have to calculate the kinetic energy of Richa at point Q. So here Richa is at rest at point P. When it will start its motion, it will have some velocity and it will reach at point Q. The velocity is given, velocity is simply 10 meter per second. So first we will determine the kinetic energy of Richa at point Q. So now given value, first we will write given value. V is 10 meter per second and G value is 10 meter per second square. Kinetic energy, first we have to determine kinetic energy at point Q. It will be equal to half mv square. Half 40, mass is 40 kg and v is 10 meter per second square, so it will be 100. So here 220 and 20 into 100 is equal to 2000 joule. So we have got the kinetic energy of Richa at point Q. So now come to the second part. So now in second part, we have to determine the vertical height of point P above the ground. We have to determine the vertical height of point P above the ground. This height, this height h we have to determine. As you can see from the figure, the Richa is at point P. It has some height h. So there will be potential energy and kinetic energy at point P will be 0 because Richa is at rest at point P. So total energy will be, that is your total mechanical energy will be sum of potential energy and kinetic energy. So now we will calculate total mechanical energy at point P first. So now total mechanical energy at point P. Total mechanical energy at point P is equal to kinetic energy at point P plus potential energy P dot E at point P. So your kinetic energy at point P is 0 plus potential energy at point P mgh, and if you will calculate, your mass is 40 kg into your g is 10 meter per second square, and your h, we don't know the h, so it is equation number 1. Let it be equation number 1. Now we will calculate after this total mechanical energy at point q. Okay, so now total mechanical energy at point q, mechanical energy at point q, energy at point q, at point q, which is equal to kinetic energy at point q plus potential energy at point q. So here, if you will see the figure, at point q, potential energy is 0 because height h is 0 and the particle has some kinetic energy at point q. We have already calculated this kinetic energy. So now what was your total mechanical energy at point P? It is equal to 40 into 10 into h. 40 into 10 into h, and it will be equal to, from the law of conservation of energy, to the total mechanical energy at point P. Total mechanical energy at point Q. Okay, this, if you will see the figure, from the law of conservation of energy, total mechanical energy at point P should be equal to the total mechanical energy at point Q. In other words, total mechanical energy at point P, that is at top, should be equal to the total mechanical energy at down. So now 40 into 10 into h is equal to kinetic energy, that is what we have got, 2000. We have already determined this, so your h will become 2000 upon 400 and 0045. So we have got 5 meter. So we have got our height h as 5 meter. So we have solved, we have solved our part second, that is height h is equal to 5 meter. Now come to part C. What is part C? Part C, in part C we have to determine the kinetic energy of Richa at point R, and they have given one condition: while moving from Q to R, she loses 500 of joule of energy against friction. So now your total mechanical energy at point Q is 2000 joule. Okay, we have already determined this, and at point R, Richa will lose 500 joule of energy against friction. So here total mechanical energy will become 1500 joule. So now we will solve part third. As we know already, total mechanical energy, total mechanical energy, mechanical energy is equal to kinetic energy plus potential energy. So now at point R, at point R, total energy is equal to kinetic energy plus potential energy, and we have to determine the kinetic energy, and total energy at point R is 1500 joule, because Richa has lost 500 joule of energy against friction, and we don't know K, that is kinetic energy, plus potential energy is mgh. Okay, at R, at so now we will determine the potential energy at R, that is UR is equal to, your mass is 40 kg, G is 10 and H is 3, and if you will multiply this, you will get 500 1200 joule. So we have got our potential energy as 1200 joule at point R. So your total energy was 1500 joule is equal to kinetic energy at R plus 1200. So if you will simplify this, you will get 300 joule of energy at point. So we have solved our problem. So this was a very nice problem. If you like my problem solving technique, then please like, share and subscribe my YouTube channel. That's all. Thank you.